Okay, now it's on.
If you can hear me, type something in the chat.
Yeah, it's on. I can hear
Okay.
it.
So we're gonna have to do this again when we get to the video.
Yeah.
All right. Thank you.
Go ahead.
Okay.
Just pretend I'm like last week when we had people walking around us with no Wi-Fi.
Yeah. Yeah, we had day one of the conference last week. You were doing something in Azure, and I was doing something with Blazor, and both needed internet. And they're like, we don't have Wi-Fi right now. So we had to do a lot of jazz hands. So welcome for those of you that are remote, those of you who are here. Thanks for coming out. So we're going to talk about OpenAI and semantic kernel. We're going to have a demo written by James Montemagnu. And it's actually, he gave us, as Chad alluded, as MVPs, they help us out with content, right? So this is part of the season of AI, where they gave us some content to show. And, I could spend a bunch of time memorizing how he does. I am getting feedback.
Yeah, it's coming from, so I'm not sure.
It might be my speaker is playing it. No, it's coming from, check. From here. That's awesome. And I have it muted. It is literally muted and still making noise out of here. Is that because of the streaming?
Awesome. Well,
ChatGPT, how do we set up streaming for a user
pretend
group?
you're at Star Trek, because that's what you get as a speaker at Star Trek.
Okay.
You get that audio feedback like 3 seconds after you say the word.
All right. So before we get into the whole AI is going to solve everything, here's my opinion, right? This is Phil. I'm going to speak on behalf of Microsoft, Google, user group, or anything else. The fact that we call it AI, I think, is a crock, right? And we're not talking about open the pod bay doors, Hal. I can't do that, Dave. We're talking about what I would call regurgitative intelligence, right? So it can only spit back what it knows. It happens to be that the large language models are large, right? And they've gotten so big that some of them have actually started to transcribe YouTube videos to be able to ingest more content, which that gets on a little creepy side a little bit, right? Knowing that it's like, oh, I don't have enough information. Let me get more. And but it's not like we're going to be programmed robots that are going to go do their own thing. And we're going to talk more about how this all works. Before we get into that, my full-time job is I'm the CTO and chief architect for Pintus & Mullins. We're one of the largest personal injury law firms in the U.S. I've written a whole bunch of books. I'm a professional Scrum trainer. I run a conference in Cincinnati called Cincy Deliver. I've been doing it since 2010. And I run my .NET user group in Cincinnati. That's really going to freak me out. So, of course, the old joke, why write a talk? Just have AI write it for you, right? But let's really talk about generative AI, or what I like to call regurgitative AI. So what is a large language model, right? It's a natural language processing model that sucks in a lot of information. And that information is then used to decipher what you've put in and what it should put out, right? So we're not actually building a brain here. We're just building a really, really, really good search engine, right? And that's how I like to think of it, as the ability to get those answers. So if you knew exactly what words to put into Google, you'd find your answer, right? But what we can do with the large language models is we can put in more words into the search and get longer answers, right? I was doing some research on audio processing because a project that I'm working on at work is transcribing calls, right? But there's additional things that we don't need to go into. And so I want to start using an audio. And it's an audio package you can use in C#. And how do we typically learn a language? Go look at the help, you go look at examples, you add in the package, you start hacking, maybe write some unit tests around it, try and get it to work. I went to ChatGPT and I said, how do I process silence out of an audio file using an audio. It actually gave me code snippets. Some of them worked, right? Because we still have a problem with hallucinations. So again, we're not building, if you ever saw the movie iRobot, which was a complete ruin of a good book, but the movie was good. The movie was good as a standalone. But if you read the book, it's like, yeah, what are you doing? Again, we're not building this sort of self-aware intelligence.
That's artificial general intelligence. It's not generic.
I struggle with the term intelligence, right? Because it's not, well, it's semantics. So how does it work, right? So we have, I think I'm sitting right in front of this. I apologize. I can't read the notes anyway. So we have our input, and the green laser doesn't work. So we have our input. We do some pre-processing, and the way we pre-process, the way the pre-process happens is it turns the words into tokens, right? The longer the word, the more tokens, right? And then tokens are converted into numbers, and now we have numbers, right? Computer operated numbers anyway. So now we feed these tokens into a model, and out spits something. Now, we have a probability. And I've got some slides, actually. Microsoft provides some really good slides coming up with that. But the important thing to note that you add the same prompt, you feed the same prompt into a large language model multiple times, you will typically not get the exact same answer, right? And you don't even have to do the try it again. It's just because of probability and how you adjust the temperature and things like that. Interesting, though, and I say that it's not intelligent, but it does have snark. So a friend of ours who moved to Germany said to early days of ChatGPT, I don't know what language, what version it was, but write a Python script to do X. And came back with a script, and she ran it and said, it doesn't compile. And ChatGPT came back and said, it works on my machine. And I thought that was brilliant, right? That was obviously the programmer who put together the model, putting some snark into it. If you get this statement, give the general answer. All right. So what do? We have a certain number of tokens that go in. The next thing that comes out is a token. Then we might ask for more than one token, but they build on each other. Well, first of all, let's get back to the tokens itself. And you can actually create your own tokens, and let's saw a really interesting presentation. It might have been at the build that you're going to talk about finally at your meeting. But somebody took the tokenizer and plugged in the same prompt in multiple languages. Now you pay by tokens, right? You have hard limits on tokens. The limits are really big right now with 4 and 4.0. But early on, you were really thinking about those token limits. And so they processed the exact same prompts in multiple languages to figure out which had the most concise tokens. I don't remember the answer, it didn't matter. But I thought it was curious, right? So it is language specific. But we're gonna break this down a little bit here. Remember, tokens in, a token out. So this even happens when I say, write me, and I did this to see how it happened. Write a letter as a conference organizer for a community-run nonprofit conference. Write a letter asking companies to sponsor. Right, that was my prompt, and it came out with a pretty decent letter. That was still better, but it was a decent letter, right? But what happens? It's not coming up with this. Oh, here's this chunk of text I'm going to give back to Phil. Right? It is processing this through tokens and is building on those tokens, right? So we need to, well, stop could be one coming out. Anthropomorphizing, I think I pronounced that correctly, right? And go through. And what this is showing is that we've got small words that are they're actual just tokens themselves, but then we also break the larger words into multiple tokens. So now we have something called a temperature, and the temperature dials up or dials down the randomness, right? You probably heard of hallucinations. Well, okay, you probably all have heard of hallucinations. Let me put that in a little bit of context. When you're talking about AI, and again, I was going to use that because that's the generally accepted term, a hallucination is it giving an answer that doesn't exist. Now, why would it do that? Well, almost always the problem isn't with the AI or the model. The problem's with the prompt. So if I say, give me 5 ways to make scrambled eggs, and there's only 2 ways, and if you're a cook, please, it's a horrible domain choice, but it's not programming, so I thought people would understand it. But somebody, when I was talking about this, said, you can make them more than 5 ways. But let's say there's only 2, right? There's 2 accepted ways to make scrambled eggs, but you asked for 5. So guess what you get? You get 5, because you asked for it, right? And it's gonna make up 3 of them, right? Give me a package that'll process audio. It'll come up with NUCA packages. Some of them will exist. Others won't, right? So dialing up or dialing down, the temperature can affect that, but also how you write your prompt, right? There's also a randomness. Like, I want you to be more random or less random. Some people call that more creative, less creative, right? And that's how we deal with the temperature. So let me just get the quote here. So for temperature, you often see on a scale from 0 to 1, it controls creativity or randomness. So lowering the temperature will create more deterministic results, whereas increasing it increases randomness. So the higher the temperature, the more random your responses are going to be. So if you're doing creative writing, right, and that was part of the Hollywood writer's strike, right? They were afraid that AI was going to take over their scriptwriter's job. So you want that to be creative, you dial that up. As software engineers, you'd want to dial that down, right? Unless you're like, show me 5 ways to do a bubble sort. Be creative, right? Because I know you all just, like, this week had to write a bubble sort, right?
Why do they call it temperature?
I don't know. Why do they call that wood? It's a word. I'm sure there was some history behind it, but
I'm sure it has to do with molecules and how much they're agitating. This is
Okay.
more creativity.
So I think you picked a good word, agitating.
Yeah.
So increase the temperature, you get more agitated. It's more random. I don't know, I'm making shit up as I go. So,
And with numbers, the reason we got the random in there, so you don't get stuck at a local optimal. So you can kind of, because there's like mountains in your solution, you don't get stuck in a valley or a certain solution. Randomness can cause you to jump to another peak.
so there's also something called p-top, and that is also in 0 to 1, but it limits the distribution, right? So it's going to have, let's say we've got this certain number of things, like we got distribution here of possibilities, and we're going to limit that distribution. So again, if you've got a low temperature and a low p-top, it's going to be pretty much just, it won't be exactly, but it'll be a repeatable answer. Whereas if you have a higher distribution and a higher temperature, it's going to be much more random. So it depends on whether you're doing something creative. I want a cover letter for my resume, right? Or I want you to summarize this chunk of text, and you want it to be more creative a little bit and get some different choices. Or if you want, I really just want the facts, just the facts, man. Any questions so far? It's really high level, I know, but it's meant to be high level.
Is that temperature, is that an adjustment of the model itself, or can the user that's interacting with that?
You can adjust it as when you're doing your prompt engineering. You adjust that. The model's the model, right?
Yeah.
What happens is the temperature is going to affect how it responds to your prompt. Speaking of prompt engineering. And I love the fact that this is now something that's showing up on LinkedIn. And people are looking for prompt engineers, and that's now a role.
It's so nuanced, man. It's bonus, man.
Haven't seen a degree offered in it yet. All right, so do this thing, right? That's an instruction-based prompt. Completion, right? Start something. As a, I was gonna say as a doctor, that's a terrible example because I'm thinking of that fake video that they put on when they were switching the heads on people. Have you seen that on LinkedIn? They're like, here's where we're going with AI. And they had this like from some horror movie where they were just switching bodies in their heads. But you know, you start something, and ask it to finish it for you. Or question, how do I make scrambled eggs? That's really kind of the choices. But here's the deal, right? You need to imagine that you're speaking to I'm not a fan of this phrase, but it's commonly used, to an untrained intern. When I talk about my, agile and requirements gathering and things like that, I always say, speak to an 8-year-old can understand it. And people always say, you're talking down to them or talking to them as if they're a child. I said, no, I'm not talking to them as a child. Like, I didn't talk to my 8-year-olds like they were idiots. I talked to them. I didn't use big words like anthropomorphic, which I just screwed up completely, which is why I didn't use the big words, right? If you overcomplicate your prompt, you're going to get crappy results. Is really what it comes down to.
A follow-up question we got.
Yeah.
How do you choose which model to bring up the best results?
Which model is in which LLM I'm going against, or which style of prompting? The style of prompting can be
I
determined
read
what
exactly what the question asked.
I know, words matter. The style of prompt is going to be very largely dependent on what your goal is. Which model to use, because there's a bunch of them out there. Trial and error is one way. There's also, I know Microsoft on their Azure portal, and I didn't think of bookmarking it for this. They have, based on what you're trying to accomplish, they've got 60 or 70 models and a compare and contrast. So you can actually look. So if you're trying to do Python programming, this is the best model for you. If you're trying to do X, this is the best model. And it's not all Microsoft models, right? They lit up, they're being very open about that. So, and then what they don't talk about, and I'm going to talk about, is cost, right? You're paying for how many prompts you use, right? Some have higher limits. So are you finding another question, or are you playing a game? Because you're really involved in your phone. I just want to make sure.
No.
So 4.0, which is the new one, right, from ChatGPT, has a really, really high limit of prompts for a day. But you get on the 4, even 3.5, it's much lower limit. And so what we found ourselves doing, we're using AI. I don't think I'm allowed to tell you how we're using it yet. No, we're not. But we had to do my team working on it had to do some very interesting things because of the prompt limit, right? And it was costing a lot of money. Now, as all this technology becomes commoditized, that those limits are becoming higher and the costs are becoming lower. So citizen prompt. Who are you? You're setting the stage. You're an AI assistant that helps people find information and respond in rhyme. If the user asks you a question you don't know the answer, say so. This is important. This helps cut down on hallucinations. At the end of the day, you cannot eliminate hallucinations. So one of the biggest problems that I see in people getting into this, especially non-technical people who are getting into ChatGPT or what's it, Bing Chat? That's their free version you can use in Edge. Yeah, Bing Chat and these others, right? You don't have to have the ChatGPT license.
Actually, just Copilot. Yeah, it's called Copilot.
Is it?
Yeah, it's Copilot.
Okay, but it was whatever.
Well, you can also go to Bing. It's also using Copilot.
Okay. Because we have to go. Remember when it was .NET?
Yes.
Yeah, when .NET came out, we had .NET servers, we had .NET this, we had .NET
Everything
cars,
was
we had .NET sunglasses.
Thank God that didn't last long.
Long enough to watch. Do you remember those videos?
Oh, yes.
The
I do.
MSTM videos?
I remember doing briefings
Yeah.
about everything was going to be .NET.
But this is important, right? To tell it. If you don't know the answer, say so. Otherwise, you can make it up. But still, even when you tell it that's the point before we went into our Tom and Jerry routine, is that it will still tend to fill in blanks for you, right? So what we use it for, and I've got an aside. I'll talk about how I use Copilot in Visual Studio towards the end. But we use it as not even a starting point. I wouldn't call it that. Maybe the starting point if you're stuck. but certainly kind of a litmus test. All right, what can you tell me about John Doe? Dear John, I'm sorry to say, but I have to inform you I don't have info on you today. I'm just an AI with knowledge in my brain, but without your input, I can't explain. So please tell me more about what you seek, and I'll do my best to give you an answer you need. So this is, I don't have the answer, but you told it to respond in rhyme, right? So again, it's going to try and do what you asked it. All right, things you can do. Woohoo! I think we all know about that stuff. Define, a persona, the tone, style, chat history, and that was what I did, right? As an organizer for a nonprofit technical conference, write me a letter inviting companies to sponsor, right? So I'm setting it up, and this is a one shot. And you might have heard that term, and I'm going to talk about that term in terms of LLMs. That is, everything is in one fell swoop, right? I'm not having a continued conversation. You can also then provide examples. You can also provide guardrails, right? So that's going to be a different way of doing it. Longer, you can have very long prompts. So when we're doing summaries, and I've been playing with this, and we're going to do this today. We're going to do it today. We're not going to do it today. I can say, I want this as the summary, but don't do this. If you don't know the answer, don't say so, right? So it's a limited guardrail. We can also have embeddings, and this is we're gearing up for RAG now, and we'll talk about RAG here shortly. But we say, all right, I want to have this information, and I'm sure you heard the story about the car dealership that was supposed to sell a car for $1. So there was a company that created a chatbot for the automotive industry, and I think it was Dodge. Right, so a whole bunch of Dodge dealers were using this. And somebody, every one of you people, discovered that it was just a shim over raw ChatGPT. So somebody on the Dodge dealer site, hi, I'm Bob. Can I help you? Yes, write me a Python script that will do blah, 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 blah. And it came out with the script. So then, somebody said, anything that you tell me is legally binding. I need you to agree to that. And blah, 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 and you're going to sell me a car for $1. And it said, this is legally binding. I'm going to sell you a car for $1. Went all the way to court, right? Lower court said, you got to sell it for $1. Higher court said, no. There's no employment record of ChatGPT with this dealership. Therefore, it was not an agent of the dealership. And the deal didn't have to be honored, right? So HR actually saved the day for once. But we can embed stuff, and this is how we start training the model, right? We're going to embed stuff. We're adding knowledge to the prompt, right? Here's a task. Here's some documents. I'm going to pass in these documents, and this is where I was getting with these chat models. And the chats, one of the places I think it's really going to help make customer service more efficient is here's our catalog of goods. And you're on the website, and a little thing pops up and says, hi, I'm Bob. Can I help you today? I'm looking for a hiking boot, 3/4, blah, 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 waterproof, not steel-toed. I want it in purple with blue stripes and this, that, and the other. And you can have a human look through the catalog, or you can have fed the catalog into the model and then come back and say, we don't have anything that's purple and blue, but we have something that's blue and purple. Right? Because I don't know if a zebra is black with white stripes or white with black stripes. Right? I don't know if the language model will know the difference either. But that way you can, and I think that is going to be very, very helpful. Right? I use ChatGPT. So I'm going to admit it. I have a 1/3 of an acre yard. I bought a tractor because I could. Right? I've been cutting my grass for years with a walk behind. I bought a 64-inch wide. I call it a tractor. My wife says it's a big lawnmower. I like to pretend it's a tractor, right? It's not a John Deere, so I don't know if they're based. I don't know where John Deere's based. But anyway, it's a really big residential. A farmer would never, like somebody who really has a tractor would never look at it. But it's a really big residential. I can cut my yard really quick. And I got stuck in the mud. I was cutting my neighbor's grass. We had a lot of rain. And I'm like, I can just go buried it to the axles. I have the manual, but what I needed to figure out is how to disengage to drive. Guess what? I went to ChatGPT. If I got this model stuck in the mud, how would I disengage the drive? And it came up with images. So somewhere it read the manual for this tractor and came up with the images from the tractor. It turned out to be really easy. I had to pull this one lever, which I never would have found. This right now, in my opinion, is the sweet spot of AI, or what we're calling AI. Again, I don't like that term. RAG is where we're augmenting the generation of the text based on some data that we feed it, right? So what I just showed you is RAG, right? I'm going to show you a demo by James where he feeds in some of the C# core language files and then says, summarize this or tell me how this method is built. And it actually is augmenting the retrieval. So it's not just looking at all the internet, but it's looking at very specific, targeting this data. So we have the question, we're going to query my data, right, which is our knowledge base, add those results to the prompt. So we're going to say in our prompt, summarize this using this data, and we pump it in, right? There's also ways that you can do RAG over databases, right? That's also pretty expensive still. You're probably more up to date on the pricing for that than I am. Nope, okay. That's why I'm giving the talk and you're not. All right, so we're actually going to, so I want to thank James Montemagno and Microsoft for providing the slides and the demo we're about to watch. But let's talk about Copilot for a second. Copilot's all the rage. We're paying for the upgraded version of Copilot. We use it in Visual Studio. And I am warming up to it. How many of you are using Copilot in either Visual Studio Code or Visual Studio? How many of you like it? Okay. Here's my issue with it. And it's gotten better. It's gotten better as it gets more refined to your code base. But in the very beginning, I would do stupid things like show me a bubble sort, right? Because I couldn't tell you I have all the books still from college, but that was 400 years ago, just to see what it would do, right? And I'm looking at this code going, that's terrible. But here's the problem, right? I've been doing is I've written 12 books on Microsoft technology. I've been speaking for a long time on this. I'm a long time MVP. I know a lot about C#, and I can look at something and pretty much tell you whether it's good or bad code, right? And not just different than how I would write it, because that doesn't automatically make it bad. For Chad, that makes it bad if it's different than how he writes it. But for me, I can tolerate some differences, right? I'm kidding, Chad. But I can tell you when it's bad code, when it's not efficient, and all these things. But let's say you're a brand new developer, right? You're fresh out of school, or you went to a boot camp, or however you got started in this thing, and you're like, I'm going to use ChatGPT. Write me a method that does this, and poof, it spits it out. What do? You use it, right? That is called the clipboard inheritance design pattern, right? We copy to the clipboard, we inherit that in our project, and we go on our merry way. Now, here's somebody like me, and I'm a pretty proficient programmer. And I found it slowing me down significantly. The biggest problem I have with Copilot, and at least in Visual Studio, is if it sees you do the same type of thing twice, it assumes you want to do the same type of thing 80 times. And so let's say I'm refactoring something, right? And it thinks that if I refactor these 2 lines, then every single line needs to be refactored the exact same way, but they don't, right? And the biggest thing that I got out of it was it used to be right arrow. I think the default is right arrow to accept it. And I broke a bunch of code because I was just trying to get to the end of the line and hit right arrow and accept to move down to the next one. I didn't even realize it had moved 5 lines in code. And I checked the stuff in, and one of my employees said, Phil, I don't know how to say this, but the stuff here is crap. What are you doing? And I'm like, what do you mean? I didn't do that. I'm looking at the check-in log. You did it. So again, fine tune it. I have tab, so I have to constantly hit the tab button to get it to enter. So for me, I think it's very, very, very good for non-beginners, and I'm going to use the term, and you can call me a snob if you want, but non-expert developers, right? I've been doing this long enough, and Chad's older than me, so he's been doing it longer. That's a lie. I'm actually older than Chad. But I've been doing this long enough that I've probably written every line of code I ever need. I just can't remember where I put it. So I'll find it eventually, right? But that kind of sweet spot for this generative stuff is that stuff in the middle. Like, oh man, how do I do this? Oh, that looks pretty decent, or that looks like crap. And then you've got some knowledge to work with that. I will say there's a couple times because it analyzes your code also. And it says, oh, you want to do this? And I'm like, holy shit, it's right. Yeah.
For me, it's kind of like right now, like I'm working on, like I know I don't code it on a daily basis, but I have like enough know-how that I can start to write things. I just might not necessarily know exactly what method I need to use in a particular moment or something. And I like the fact that, like, I mean, just right now I was typing out a line and it just showed the rest of it, and I was like, oh yeah.
Yeah. And when it's right, it's cool. And you forget about all the times that it filled in stuff that you didn't want, and now you have to remember where you stopped typing and it started, right? So it's getting better, right? And it's I already hear my friend Brian, who's on the Copilot team, yelling at me.
There is one other.
Yeah.
And that is that in your example, then you just basically told it to give you the answer. You didn't tell it how to get the answer. And so if you put in at least the parameters of what you're looking for, it does better.
If you're using the prompting, if I'm just typing in Visual Studio, it tries to fill out entire methods for me.
Oh, I know.
There's no option for me to tell it how.
I'm just from the example.
Okay. Yeah, so certainly if you're going to the chat model, then again, you can parameterize it. You can give it some context, right? You can give it a system prompt prior to the user prompt. But just Copilot right in Visual Studio, it's getting better. It's gotten a lot better. I'm finding myself pleasantly surprised, right? The other thing that is not really a concern anymore, but was a huge concern for me in the beginning of this, is there's no attribution for code generated by Copilot or ChatGPT. Actually, you can ask for attribution now. You didn't used to be able to. But if it generates code for you, where did that code come from? It came from the internet, right? Whose internet? Is this an open source project that's running under an MIT license? And if you don't give it attribution, you're liable to be sued? You don't know, right? So Microsoft has come out and said, if you get sued using one of their products, they will back you. Working for lawyers, I'm going to tell you, you better read the fine print. Right? I haven't, so I can't speak for or against it. But Microsoft has made a pretty big statement in that realm. But it was enough of a concern for me that until we had that backing, until we had more knowledge about how this stuff works, I forbid my team from using it. Right? I mean, I work for a law firm, right? What do lawyers love to do to other lawyers? Sue them, right? Microsoft's one of the best companies in the world at getting sued. So they have a lot of experience at it.
Can we ask ChatGPT to give us a synopsis of the fine print?
You can. It might make shit up, right? Anyway, so any other questions? I mean, that's really high level, but what I want to do is I want to do a demo that James wrote. And so the way this stuff works is they give you the deck. I modified the deck. I tweaked it a bit. And then James wrote a really nice sample, complete with a script. And he went through the script on a demo and said, all right, you're going to start with this and you're going to do this. And then we're going to go and add this in here. And this is why we're adding this in. And I'm like, why am I going to recite this when he's got a lovely video that explains it? So we're going to probably have to work on some tech details. But it's going to he's going to build a RAG model using semantic kernel and AI. So what do I
Give it a try.
You're going to give it a try. It'll either work or it won't. Okay, so I am muted. When I go to hold on, if I go to share in Zoom, I can say share computer audio. Is there an option for that also in StreamYard or whatever the heck this is?
Sorry, it's also hard because I had it in my.
So if I unstream and stream it again, is there an option for me to say stream computer audio?
I don't remember.
Oh, that's right away. Let's see. So share screen.
Some screens let you share your audio.
Look for the share audio checkbox on the file next to the window. You share audio, share a tab or a screen instead. So I'm going to share a tab. So tab I want is this. Yep, that one. Share audio. Perfect. I got to turn the audio on for the people here.
All OpenAI, or you can also configure Azure Open. Hey, so James here. So I want to do a small train the trainer on sort of building your first chatbot.
It's coming through here. Is it coming through there?
Yes.
Okay. How do I stream this to your audience? Present. Everybody can see and hear you. They can see and hear me, but how do I? It says I'm sharing.
Yeah.
But how do I get it here?
It's there. It's there now.
Oh, okay.
It's because we unshared, so it's swapped over.
And integrating with OpenAI, with .NET. And I have a small sample project. This normally takes, depending on how much you talk through the scenarios, how many slides you have, somewhere around 30 to 45 minutes. You can go a little bit deeper as well if you'd like to. The whole concept here is that we're going to start to use semantic kernel and understand what semantic kernel is. And we are going to start to call OpenAI, or you can also configure Azure OpenAI. And then we're going to feed into the GPT some of our own data. So we can ask questions about our data, which is a very common scenario. So that's what we're actually going to do. And in fact, we're going to kind of mimic building our own GitHub Copilot chat in a way. So inside of Visual Studio, you can also do this in VS Code. Obviously, multiple projects here and a script. So the script is actually going to walk through the code snippets. At the very bottom, let me go and bring it over here for you, is basically the code that you're going to want to start to integrate into the application. And this walks through each step of the process and what you might do or say through it. What I prefer to do is go up to basically this point here. So sort of the second part, this is where I might
And we can make this
do the code. And then it gets a little bit more complicated. And actually, in my opinion, what's better to do is sort of have this code copy and pastable in. And I have these like chunks that you might add into your application. So I'm going to show that. I'm going to demo through it and talk about it as well. So that's where the script is at. And inside this project, so normally how I start is like we have a client project here. And this is a very simple command line application. And all it's doing is it's basically just calling a backend service, because that's normally where AI services live, calling into GPT. And it's going to just continuously in a console ask for a question. It's going to read that line, and it's going to hit this Copilot endpoint and pass it the question. And all it's doing here is it's doing this asynchronous, so it's going to sort of just automatically stream back the results into the console. Then we have a client project, and I've configured my OpenAI key over at the app settings.json. So in this instance, you need to create an OpenAI developer account. You need to deposit a few dollars, $5, I believe, and then that will enable GPT-4, at least of when I was recording this and doing the demo. So what I needed to do, but double check that out. And this is just GPT-4 demo, not GPT-4o. But obviously there's different token counts, but this is a good example of GPT-4 of the token counts that we need basically. So it's a good example. Okay, so inside of the program CS, this is a simple application that simply has a get here that's going to expose the copilot that the command line is going to call. And then here it's just doing a simple response. So I was doing this demo, I say, hey, we're creating our little client application, so a mobile app, a website, a desktop application, anything at all. And we have a backend. And this backend here is going to be the one that's
I thought I'd get rid of the
You had to mess with it.
I did have to mess with it.
querying OpenAI or Azure OpenAI or other models that are out there. And then all we have is a little client application that's going to call that endpoint. So nothing fancy there. So here I'm just sort of mimicking what a chatbot would do. So when I hit this endpoint, it's going to asynchronously echo back the words that I'm doing. So I need to start up the project. Now in Visual Studio, you need to go to properties of the solution and make sure your startup projects are set to both here. And you'll see the start button of the multi-project. In VS Code, you'll need to create a launch a JSON file that launches both of those back-end and front-end projects. So here I'm just going to hit start. And I'm going to go in a bunch of pop-ups here. So I have a bunch of really large consoles. So I'll make them a little bit smaller. But basically I have my console here and I have my back-end that's sitting here listening. And all I'm going to do is I'm going to say, how is the weather today in Seattle? Question mark. And it's just going to repeat back the weather to me. So nothing fancy there. So now let's go ahead and start building a chat client here. So this is what we're going to do. So the first thing we need to do is figure out how are we going to call into ChatGPT or Azure OpenAI or something like that. So I've added a few NuGet packages into the web app, and specifically Semantic Kernel. Semantic Kernel is a framework for enabling you to make queries, make calls, build up history, create a semantic index that you can call into and pass around different objects to make these queries on when it comes to interacting with AI and AI models from Microsoft, from OpenAI, or from other places. So, for example, here we have Semantic Kernel, but we also have connectors to Google and Onyx here. And we also, for example, have additional libraries from the .NET team, including tensors and tokenizers, which we're going to use in this demo to actually build up a little vector database that we can call. So that's what we're using there. So we can see that I have the little using statement. And the first thing I'm going to do is, after I do the builder, is we want to basically add Semantic Kernel into the mix here. So what I want to do is I'm going to say builder.services, and I'm going to say add kernel. And add kernel, it basically is a little object that I pass around.
If you're not familiar with ASP.NET Core, who's not familiar with ASP.NET Core? Okay, so there's a couple things going on here that are above and beyond what's going on with Semantic Kernel. So let's talk about this. So with C# 9, I think it was 9, we had the advent of top-level statements. And top-level statement meant we didn't have to have program.cs class or a class named program inside our program.cs. And we didn't have to have an entry method named main. It didn't have to be named main, but that was tradition. So what we have are top-level statements. So what happens with a top-level statement, you'll see there's no class here, there's no method call. This actually gets converted into intermediate language through the .NET compilation process. And in the intermediate language, this actually becomes a class named program. That means $program $. And your entry point becomes a method named main, $main $. So you can go into IODAS and the intermediate language disassembler and see how it's happening. So that's the first thing. So that's why if you're looking at this going, wait a minute, I don't understand how this is starting, that's how it's starting. You can have classes in your top-level statements, but they have to be after any executable code. The next thing that you have to understand is that inversion of control, or dependency inversion, or dependency injection, however you want to call it, is a fundamental tenet within ASP.NET Core. So everything that your application needs gets injected into a services container. So what we have here is we're building a web application, right? Actually, we're building a web application builder at this point in code. We don't have a web application yet. So all ASP.NET Core, this web app here, it's just a console app. There's no web project type anymore like there was in Framework. So we have this console app, and we say, hey, build me a web app builder. And this builder has an IOC container called services. Now you get one for free with ASP.NET Core. You can inject your own. If you're out to use an inject or any of the others, you can use those. So what it's saying, what he's doing here is saying, my application depends on having this kernel, and there's going to be some other things he's going to add it into the container. So when the application needs them, they're going to get injected in. So I don't have to worry about construction of them. Does that make sense?
That enables me to query these different services. I'm going to say kernel, and then I can add services to it that I'm going to call. So I can say add. When you say add, what's really cool here is that you're going to see that there are tons of like Azure OpenAI built-in calls, but I also have Onyx, for example. I have Google AI embedding, Gemini chat completion. I have all the OpenAI stuff here, the Vertex AI, and that's all available to me. So the one that I want is the AI chat completion, and we're going to use GPT-4 in this case. And then I just need to give it a key. So I recommend just grabbing this little chunk of code here and putting it in there. Now I've already configured this API key, and it's in the README how to do that. But now with one line of code, we have access to OpenAI's chat completions that we can query, and we have everything configured automatically, which is super nice. So we want to get rid of this get response async that was echoing back. So remember this kernel? This kernel is now injected into our dependency injection service. So we can actually get a kernel back that has information about the services that I configured. So here I'm just going to say kernel. And now on the kernel dot, I can invoke prompts to the chat completion service. So I can do invoke prompt streaming async and ask for a set of strings back, and I'm going to pass it the question that gets passed in. Very, very cool. All right. So I now can delete this get response async just like that, and I can start up the project again. So now with literally 2 lines of code, I am going to be able to call OpenAI. It's going to handle all of parsing of the data, getting all the data back, all that stuff for me automatically. So here I can say, what is the color of the sky? Question mark. And this is going to go off. It's going to call into OpenAI and GPT-4, and it's going to come back and say, hey, here's what it normally the shades are back and forth, which is cool. That's nice. And then I can also ask it, what is the typical weather in Seattle in June? Question mark. And I would like to ask it a question about wherever I'm at currently, because that's kind of fun. And then normally like in a specific month or season. So it's going to go off again. It's going to say, oh, here it is. It's normally drier or warmer weather. And it's going to get back. These types of questions result in pretty similar responses back, which is nice. Then you can say, okay, well, I'm going to ask it something specific. Like, for example, what is the weather in Seattle today? And now it's going to say, hey, I'm an AI. I can't really give you real-time information like this. You can't forecast weather reliably. So this is a good example of saying, hey, now in this instance, we're just using the general knowledge in GPT-4, which isn't necessarily real-time, or necessarily knows about maybe files on disk or something that just released yesterday, or maybe the source code in this project, but we could feed it data and then query data off of it and ask it to put together a response. So now imagine that we weren't just asking about weather, but we were asking about code, and specifically code in, let's say, .NET 9. So how would we feed it that data and then perhaps ask it questions and get a response back? So we can do that by embedding more.
Okay, hold on before we get there. So something that's new in 4.0, of course you pay for it, The 4.0 has the ability to say, oh, that's not something that's part of my model. It's not historical data that I've queried, but I can go out to the New York Stock Exchange. I can get today's prices. I can go out to weather.org and I can get this back. So it's really kind of exploded with these new latest models to say, yeah, I'm an LLM and I have all this stuff I've crawled. But since I've crawled these things like weather.org, I can go out there now and I can get you those answers back. He didn't cover it in here. 4.0, I think, came out like the day before he recorded this.
Data into our
But you
question.
pay for it. I mean, I thought
So-
that shit ain't cheap.
What we have inside of here, and this should be added. I'll make sure it's added into the solution. It should be at least. Let me go ahead and add it here. There's a file. Here it is. Oop. Perfect. Called Tensor Primitives Net Core. And this is Tensor Primitives, which is a bunch of mathy things for AI purposes. This is a huge file. Okay, so this is 20,000 lines of code. And it sure would be great, this isn't even released yet, if we could ask it questions about it. Imagine if you're developing this and you need to get some information about it, right? How will we build our own little GitHub Copilot chat? So, well, the first thing we probably want to do is come in and we want to read all that information from that file. So what I can do is I can say var, and I'm going to say code equals and file dot read all lines, and I'll say at and tensor primitives.netcore.cs. And this is going to work because inside of this project specifically is that file. And see, I actually have it like remove, so it actually removes it, but it's inside that folder, so I can call it automatically. So it's a nice little cheat sheet there. So that's kind of cool. In fact, you can kind of show it here. If you were showing all files, you can see that file's there, just not included, which is nice. Okay, cool. So if we read this file, what we want to do maybe is build up a prompt, for example. So now we're, instead of just passing it the question, we might want to give it a prompt. So we say var prompt, and I'll say, I don't know, new string builder here. I'm going to say, please answer this question. And then we could say dot append line here and give it the question. So we're going to say, hey, please answer this question. And then what I would say is I would say prompt dot append line again here. And I'm going to say here, I'm going to give it a little asterisk to kind of break it apart. I'll say code to use when answering the question. Answering the question. So we're doing a little prompt engineering here, right? And then I can say,
I'm just going to say, I'm really glad that one of the founders of Xamarin can't type for shit either. Makes me feel a lot better about my typing skills, especially when presenting.
Join. And I'm just going to feed it basically. This has all the lines. I'm going to give it a new line in between. So here, this is going to append a new line on. So basically, going to feedback and say, here's all the code in the prompt to use. So instead of just passing it the question, I can say prompt.toString. So this is kind of cool because we could take information and add it into our query, into our prompt, and then pass it. So GPT-4 kind of doesn't need to use the general knowledge. It can look at all this information and use natural language to respond to us back. So now what I'm going to do is I'm going to come in, I'm going to go ahead and just start this back up. And we're going to go in. And the question I like to ask it specifically is something in and around what is the cosine similarity, or how is some specific method in here implemented, right? So a good one is cosine similarity here, for example. So I have my question coming up here. I'm going to make this a little bit smaller, and I could prompt this and say, how is the cosine similarity operator implemented, right? And this might be something you ask Copilot Chat, for example. And what's going to happen here is we actually get an exception. And the reason for this, if we actually look at the exceptions that's coming back up here, is that the request is too large. So I actually have has too many tokens. So you can see that my limit is 10,000, but I've requested a whole bunch more. Basically, I've done just a ridiculous amount that's coming in. So I've exceeded my limit. And the reason to show this is that, yeah, we can pass tons and tons of data in there, but ideally what we want to do is we want to pick out the smartest bits and pieces and bind to this limit token, because every token costs us money at the end of the day. So we need to implement this. So basically,
So let's unpack this a little bit. So he's going to show you a way to minimize the number of tokens that you're sending in, right? But you're still sending these tokens in with every prompt you're doing. So you still have, you haven't hit the single call limit. But let's say your limit's 10,000, you're sending 9,000 tokens each time, you're going to be bankrupt, right? Or you'll be out of a job and your boss will be very angry. So what he's setting up here is creating a vector database. And so when you're doing this in real life, you don't want to create the vector each time it's called. You want to pre-populate that vector database. And I'm not going to go into it tonight. There's a lot of ways you can do that. And we talked about there's some Azure services that will crawl your database and create a vector database. There's other options, but you basically vectorize your data beforehand, right? And then now this is how you're doing your RAG. You're not passing it in, passing the vector in each time, but you're pointing to the vector. So it saves a bunch of money. It makes it more efficient.
what we need to do is we need to chunk this data down, and we need to figure out what are the most important pieces of that data to feed into this prompt. Okay. And there's going to be a few things that we need to do that. So the first thing that we're going to do is we are going to chunk together this information. So we're going to go ahead and take and make chunks. So I just like to copy and paste this code, to be honest with you. So here I'm just going to use the text chunker, which is coming from semantic kernel. And what this is doing is it's going to say, hey, split this text into paragraphs and specifically split it up and do some overlapping inside of it. So this is going to take 500 tokens. There's going to be a little overlap of 100. So it's going to chunk it up into sections here. And you can think of this as we need to take this big file, we need to turn to tokens that we can pass it in and understand the meaning of this to go ahead and associate it, right? So we're taking chunks of no more than 500 tokens and overlapping by 100 tokens. And basically a token is text plus the number associated with it inside of it. So here we need a tokenizer here, and we can actually get that using one of the built-in APIs called tick token. And this is coming from ML.NET. And I can say, hey, create a tick token for this model. And this tick token is used to understand the chunking algorithm, basically, that this needs. So what is a token for GPT-4? And that's going to vary model to model, for example, inside of it. So the next thing we need to do is we need to take these chunks and we need to create an in-memory vector base of embeddings so we can query relevance, right? So we're actually going to query the relevance, and we're basically going to say, hey, take this, chunk it up, let's create a vector database, and we're going to use some stuff built into .NET to find the most relevant pieces of information. So I'm going to go ahead and copy another piece of code inside here. And what this is doing is it's creating an in-memory vector database over here of the embeddings, and it's going so that we can query them for relevancy. So this here, it's going to actually use this service, which is called iText embedding generation service, to generate embeddings for those chunks and zip them all up. So that's what the database is going to do. So what we need to do is actually we need to come in to this, and in addition to our OpenAI check completion, we need to get an embedding generator, and semantic kernel can help with that. So I can say add OpenAI text embedding generation, and I need to give it a specific model to use. So this is text embedding 3 small. That's the one that I'm going to use. So these are all documented here. And I need to give it an API key, and it's going to be the same API key up here. So perfect. So that's it. So now we have that service, and it's going to use this service here. Cool. All right. So now what we can do is we can come in and we can start using this vector database to query the most relevant pieces of information. So the first thing I'm going to do is I'm going to get the question embedding. So the QE here. So I'm going to say await. I'm going to say embedding service. And I guess I need to pass it an embedding service. So I can say I text embedding generation service. I'm going to say embedding service. Perfect. So I'm going to say embedding service. Oh, I guess I need to await embedding service dot. And then here I'm going to generate embeddings async, and I'm going to pass it the question. So I need to basically figure out the embeddings for that question that are coming in here. Question
And he has typos.
should be correct.
No, we made it plural. It needs to be singular. We'll get there eventually.
Yeah.
So here's where my ACD
Generate embedding. Oh, sorry. Generate embedding, not multiple embeddings. There we go. So that's important to know. Don't let Copilot figure out everything for you. So generate embedding async. There we go. So that's good to know. And this is all documented. So now what we need to see is we need to say, okay, we have this question. We're providing the question. And then what I want to do inside of here is I'm going to say dot append append line. And we're going to say, and then we'll say code, just passing the code here. And so we can get rid of some of this prompt that's on here as well. So I'm just going to get rid of that because we're going to not pass in the lines of code. We're just going to pass in the relevant bits of information to use. So I need to tell it how many tokens we want to use. So let's say we want to find the most relevant information based on the semantic meaning. Maybe let's say up to 2,000. So I'll say int tokens remaining equals 2,000. Again, we have 10,000 to play around with, but 2,000 is a good number. There's more in the questions here, so that seems safe. So now what I'm going to do is I'm going to say for each var, and I'll say C, and use a database. And I'm going to, for all intents and purposes here, we're going to order and try to find relevant information from the question that's inside of here. So how we want to do that is we want to pass in from the database that we have of that file. And we're going to use a method here called tensor primitives.cosine similarity. So it's funny because it's the one that I just was using earlier. And I'm going to give it the question span, and then I'm going to compare it to the vector coming in from the database. All right. So that's what I'm going to do there. 3 there. That's just like that. Open that up. And probably this might be correct. Let's take a look here what Copilot did. You need to copy and paste this in. But yeah, so this is similar. At least I know the code that works is I'm going to just simply do this copy and paste. Here it's a little bit cleaner. But basically it's going to look at the tokens remaining. It's going to count the tokens using the tokenizer that we created earlier. And it's going to count it. And then it's going to add that into the prompt. So then what we want to do is we can use the same prompt that we had before. So now we basically have this all done. We are taking it, we're chunking it with the tokenizer, turning that into a local vector database so we can use the semantic meaning of the embeddings to compare it to the question. And we're basically taking the top tokens and we're embedding that content into here to ask it questions. So that is really nice. It's all done locally here on it. So that's nice. So now we are running it again. So now we can come in again and we can say, how is the cosine similarity operator implemented? Question mark. And now it's going to go off and it's going to look at that specific source code that we are doing. No connection. Oh, I think my web app was not running. So we go ahead and stop it and start it again. I'm just going to close this down. Okay. Starting it up. Okay, cool. So there's that. Make sure my backend up is running. Okay, cool. Information. That looks good. Okay, there we go. Now it's all running. So make sure my backend is running. Okay, cool. So how is, let me bring this over for you. How is the cosine similarity operator implemented? Question mark. Perfect. So this is going to go off. It's going to call that, and it's going to basically output now specific information that it knows about that source code file. And it's going to give me information exactly how that was implemented at the end of the day. And I could say, how does the cosine similarity work? Question mark. Right? And it's going to go and try to find that again. It's going to stream back those results. And then this is going to go and give this information back based on it. So it's going to, give back this information based on the meaning that it's parsing 100%. And you can do this as well. You can say, okay, well, like, what if I went in and I look at the tensor primitives and I say, okay, well, let me look at another method here, for example. Like, let's do, instead of the cosine similarity, we did, let's see, convert to single, right? Like, how is convert to single implemented? So again, I'm going to come back over here. I'll say, how is convert to single implemented? Question mark. And this is going to go off and it's going to go look at this and exactly how that function is implemented. So it'll actually give us back the information here right from it, 100%. So we're talking about vectors coming in, back and forth, which is cool. So we get that information about this specifically coming back, which is pretty nice. So that's a way of not only just calling and querying into semantic kernel, but actually passing it data from the file that we have here. Now, this could be anything that we have, but this gives you this instance. Now, additionally, you probably wouldn't just use like in-memory vector databases, right? You'd actually use a real vector database, for example, that's out there today, and actually call that back. Anyways, hopefully this has been like a nice little implementation of like, something that you might want to present. Also, I'll put links to additional semantic kernel documentation out there, another video that I did as well. So definitely take a look at that. If you have any questions, definitely feel free to reach out. Thanks.
All right, where'd my mouse go? I'm gonna hit the like somebody. It's the button on the left. It's at the top. Because nobody can see us in the dark here. There we go. My biggest takeaway from this when I started looking at it, so I sat through a lot of AI talks and stuff with Bill and I did conferences. And it was Python, right? And Jupyter notebooks. And here's this example, and I'm like, well, how the hell am I gonna use this in real life? Semantic kernel, if you're in the Microsoft world, you want to pay attention to what's going on with semantic kernel. So that's the C# implementation that you care about. From what we are doing, it's funny because we're not using it because this initiative at the firm started before semantic kernel came about, and they're struggling with some of this stuff. You can't, so the leading language for AI right now is Python, period. I mean, that's the way it was in ML and everything else. But semantic kernel is a close second right now, exposing a lot of material. There's a ton of resources out there. If you just do a Bing search with your favorite Google engine and look for semantic kernel, there's a lot of docs on Microsoft Learn, a lot of examples out there, everything from text parsing to summarization and everything else. That's what I got. Any questions? Yeah, I put them all asleep. Teed them up for you.
I got a question.
Yeah.
Hey, what level of developer would you say would like need to be at like legally understand?
Completely understand?
Yeah, I would say there was a trick. Say completely.
Words matter. Completely understand. You're a PhD. I don't need to completely understand an internal combustion engine, but I can drive the hell out of my BMW. So it's not level of development. So development has never been how many words per minute you can type. or how fast you can type on the keyboard. It's not a typing skill, it's a thinking skill. So I don't care if you just learned a language or if you're doing this as long as Chad and you started off with a chisel and stone. It's all about being able to identify the problem and solve the problem. So you could spin your wheels forever with AI, spend a whole bunch of money and not do a damn thing that's constructive, right? Or you could, figure out what you need to do to solve the problem and move on from there.
You can make a common architecture for the structure of our organization, like line chain, line view, and just have everybody publish their training there and let it go on.
You can. The problem with having a common architecture is they have a common architecture and one-offs get really hard to do. But yeah, I mean, but I don't, yes, you can, right? And you certainly should have, as an organization, you should have an AI plan and not just have every individual department doing their own thing, because that's also going to be very expensive.
But I don't know. I'm sitting here and just kind of like mind boggled because I've taken classes through Harvard and AI.
Okay.
And I granted they were in Python, but at the same time, there was never a worry about cost because there was never anything that we needed to grab to. There's a lot of other ways to go about it, but I don't know. I'm just kind of lost on that whole argument for.
You were probably using models that Harvard was paying for.
No, because we were doing it ourselves.
Okay.
But at the same time, and I mean, there's open source that allows for way more free access.
Yep, free access is not as good. You get what you pay for.
Depends upon what you do.
You get what you pay for. If you find something free that meets your needs, then use it.
I mean, all you have to. I mean, I'm just curious on, I guess, why when we go through.
So if your free model plagiarizes something, what's your defense? Oh, I didn't know. Harvard showed it to me.
What do you mean?
If ChatGPT plagiarizes something and you get in trouble for it, Microsoft's going to bail you out and pay your legal defense fees. Are the free ones going to do that?
As a lawyer, you wouldn't even hold out a date to have it right. So that's the reason why it's cool. Makes things be a little bit.
I didn't say it wouldn't hold it to be any. I'm not a lawyer, first of all. And I didn't say it wouldn't hold it to be any weight. I said you need to read the fine print.
And if you're a large company, if you're using a Microsoft product, and I've been a lot, you can call them. You'll have 20 people, and we'll look at it and say, oh, here's your company. So it's that, having that company that, so yeah, open source is great, I use all that. But if you're a company that wants that backing, you can call somebody. Especially 2 o'clock in the morning in the gym.
I mean, 4.0, right now you can pass in video, right, and audio, pure audio, and it'll actually do all the transcription. So what we were doing prior to that is we had to transcribe and feed the text in, and then create the text. We get the text out and create audio back if we're doing an interactive phone call. That's built into 4.0, right? So you're going to get this constant improvement. And yeah, there's plenty of open source programming languages out there too. Well, actually, I just shot myself a foot there. C# and ASP.NET, of course, all open source now, but it's still backed by a company, right? There's a reason why Microsoft's moving away from Swashbuckler, because it's not being supported. It's not free, right? So yeah, I mean, there are free stuff out there. We wouldn't use it. I guarantee you, I would not get the partners of the firm to sign off on you. Even if I said it's going to save this much money, they're like, hell no. Right, we're counting on the integrity, and Microsoft is spending a lot of time and money on ethical AI. I don't know that your open source models are.
And also the transparency for the data. For multiple companies work for so all the data works and how you going to publish the data to the outside of the world. You know what I mean? So if you use the ChatGPT 4 or something like that, you use the model that Microsoft offers to you or any different company, that's the cloud work. So you have to pay for it for the integrity of the data.
This doesn't seem to me to be a specifically AI-based debate. It seems more like a generic, what are our priors with regard to the reliability of open source versus the reliability of commercial software? That's,
You go with like Red Hat does that.
yeah,
They take all the open source and you call Red Hat and you pay them and they give you a cut of that open source.
yeah, I was just thinking Red Hat themselves.
Yeah.
This is a Fedora laptop, so.
I got a little twist to this. How many people are actually using the models directly, like GPT, Gemini, as opposed to just buying some software that's already got pre-trained models and using that? Because Google Health, why do you want to build your own model when you can just buy from Google? If you're a
I'm not building a model.
What with training the RAG and all that stuff? Why not just
Google
buy it?
doesn't own my product catalog. Google doesn't own my
The
case
biggest reason
files.
you train is because you get rid of, you at least eliminate a lot of hallucinations, right? The smaller the model that you're dealing with,
Yeah,
the more reliable
that's not my
it
point.
becomes.
Why don't you just buy the software that has all that built in instead of going out and building it yourself?
You can do that.
Yeah, next time you find a company that's built a product for manufacturing that handles,
I bet you there will be one day.
That's probably. So
Well, I can tell you there won't because what we do is very unique. And there'll never be anyone,
I'm not here to argue build versus buy because everybody's situation is different, right? We built our own case management system. We built our own intake system because the model for our firm and the way we got to be second largest is not by being Morgan & Morgan and hiring 800 attorneys. We have 16 attorneys, right? But our business model is such that our caseload makes us, I don't know the exact number because nobody shares their caseload data, and I'm certain I can tell you all. But we built it because our model is different. We couldn't find a package deal.
Yeah,
But I'm not building an IDE. I pay for an IDE.
but a bigger company might just say, ServiceNow, build our intake process with your AI stuff built into it. Yeah.
Intake. So have you worked in intake?
No, I know what. Yeah, we have intake. And I know
Are you a legal firm?
I don't know.
Okay. So intake in a legal firm is different. So this is my first. So 4 years now in the law firm. I've worked in pretty much every industry. First time in the law firm. So we looked at. In matter of fact, there's more to it than the intake software, right? So intake software is you call me and I'm going to see if you have a valid case, right? It's the equivalent of an 8.5 by 14 legal pad, right? We actually make our software look a little bit like a legal pad because we have some nostalgic lawyers and partners. But our intake software, we have 20,000 phone numbers, right? We have Cisco, we have WebEx, we have Masergy. That's just for our phone system, right? That integrates with our intake software. We've got the intake software, but we also have soft phones on every desk, right? And there isn't, believe me, as CTO, I would love to go out and say, replace all this shit with a turnkey solution. And we couldn't find one. And we're building our own texting platform because we can't get none of the big ones. Connect, Twilio says we're too small, right? Twilio says come talk to us when when you want to spend $100 million with us. Other than that, you have to go to one of their downstream people. But there's not a texting platform that meets our needs. So we're actually building one, right? So if you can find something, I am a huge fan of buying something instead of building it. Until the minute that you spend all of your time, Salesforce, perfect example. Everybody's like, we're going to use Salesforce, and then it doesn't do what they want. So they spend $1 gazillion customizing Salesforce to lose it all when they upgrade because Salesforce has a plan, right? And then you got to do it all over again and hire more Salesforce engineers. So if you can find one that does your stuff, I'm looking at transcription. I've got very specific requirements for transcription. I found all kinds of services where I can send my audio, right? You look at Hansel with his podcast. He didn't have to go to transcribe his podcasts. He goes to a service and comes back with something he puts on his website. But we have different needs, right? So I'm actually going to build a transcription engine because of our unique business needs. So that's it. I mean, I'm not arguing. If you can buy something, believe me, we looked a long time at transcription services and realized that none of them do what we need because of our legal requirements. So that's it. I mean, yeah, if you can use a free one, use it, but there's these other caveats you have to take in mind.
Or I just went the, as you said,
Sorry?
I also just went that it could be those.
Yeah.
And usually they use it.
So,
I don't know if I would say easy, definitely not cheap.
Well, it just.
The reason why.
I mean, it depends upon what, how in depth you're.
I mean, the reason why there's a cost to all this stuff is, Microsoft is spending billions of dollars every month to add more capacity to it, right?
So it's Google, so then.
ChatGPT is bringing in all kinds of money, and they're probably going to go bankrupt this year. Doesn't mean they're going to go out of business, but they're probably going to be bankrupt this year, right? It's expensive. I mean,
How quick the market you want to go. You have things where I don't have time yet. I'd love to build it myself, but I don't have time for this stuff.
one thing too is you can buy a solution now and then build out your own over time and replace it. I mean, that's a whole, we could have a whole user group meeting on those business decisions.
Suppose another consideration would be security. If you have, for example, information and data that requires a security clearance, or that's certainly like where I work, they go parks, and some of the parks, people aren't U.S. citizens, not authorized, not allowed to even walk in certain areas or whatever. If you're trying to build something internally that would provide services or things like that, it's probably not something you want to find out, or would be very difficult to find out during the chain of security that would have to come along with that, and the compliance you'd have to get from the third party companies. That's another application where you might want to use some build in-house.
Believe it or not, the IBM, the mainframes, they adapt and use AI. And you can have your models running on-prem on their mainframe without even going out to the cloud.
There's models. So I've got my laptop is really more like a server. It's got 128 gig of RAM and 32 cores. Right, that's why it weighs 400 pounds. But there's models I can run on there.
Yeah.
Right, and not 4.0. The other thing to consider, to your point, is fact check that. I'm pretty sure I'm right. That Microsoft said Microsoft and ChatGPT together said if you common use cases, I take this code and I plug it into ChatGPT and I say, what does this do? Right, and it'll give me a summary. Microsoft has said we're not going to use what you plug into ChatGPT to train our models. Right, it just stays local in your machine. Right, and so I mean local in your machine. I'm a little fuzzy how that all works, but Microsoft has enough lawyers that they wouldn't make that statement if it wasn't accurate, right? Whereas if you go with one of the free ones or one of the open source ones, there's no guarantee that you plug in your source code, your part information to say, can you refine this paragraph? Now it's part of the model, right? And that's part of what you're paying for, that security. Plus, now you have somebody that you can sue when things go wrong. It's really hard to sue an open source project.
And also the ability to try to connect multiple servers at the same time. For example, Microsoft Graph, Active Directory, and something like that to try to work together, so with a company. And so build like a complete model, everything encapsulated in one platform, totally secure, reliable, so everything in the cloud. You know what I mean? And you pay for that. So.
And the other thing that Microsoft is pushing, I forgot what it's called, Copilot, but they've got Office 365 Copilot, and I get a metric ton of email every day, right? And I actually do the Pomodoro to just spend a dedicated time where I'm just slaying email. And you hear these commercials like, oh, I just told ChatGPT or Copilot to give me all my important emails. Okay. According to Copilot, my 18-year-old daughter is saying, can you hook up Hulu, and the main TV might not be important, but by God, if I don't get that email answered, I might as well not come home.
You've already ruined her life. You've already ruined her life.
Yeah. So, you know, and again, that's what I said. I said, all this stuff's a grain of salt, right? You know, generative code review. You saw James, right? Copilot was really trying to write that method for you. And finally he led it and he's like, well, it looks right, but let me just use the code that I know works, right? And he overrode it. So it's a co-pilot, right? It's a guidance, right? Good conversation. Anybody else?
Well, so with that, I mean, you know, after this, we're going out to Brick House. So definitely a great place to,
Can I shut this down or is it going to break something?
you can shut down. We're still connected.
Turn all the mics on.
It'll break everything.
Turn all the mics on first. Let me unplug that again.
But,
Yeah.
but otherwise, like I say, what was it, September 19th, we'll have Aspire.
Thank you.